Okay, we're going to talk about polynomials today. Just wanted to look at a bit of terminology and some definitions. We know that poly means many, and this is numbers. What do you mean by many numbers? Well, we've talked about binomials before. We've talked about trinomials, a quadratic trinomial where it has three terms that make it up. Well, a polynomial is just made up of many terms, and that a trinomial comes under the giant category of a polynomial. So a polynomial, just in general, might look like something like this. X to the 5 plus 4x to the 4 plus x cubed minus 2x squared plus 5x plus 3 or something like that. It doesn't matter, but that's a polynomial that's written down there. How about we change it up and just put a 7 in front of there? All right. Now, for a polynomial, we're wanting real numbers to be at the front here. And we're wanting the powers to be integer powers all the way down there. And just so you know, I finished off that polynomial with a plus 3. So I might try and squeeze that in so we can see that in the video by just minus 2x squared plus 5x plus 3. Just made it. Okay, just made it in. So what are some of the definitions that we might get out of this? Well, polynomials are spoken about a lot by their degree. The degree is just the highest power. So what's the degree of this polynomial? The highest power is 5. That's right. It wouldn't matter what order you write all these terms in either. You just look for the highest power and it's 5. What about the leading term of this polynomial? It's not the term that's at the start, it's the term with the highest power. So when written in the standard form, highest power down to the lowest power, then it's easy to see, but just be careful because it's the term with the highest power, which the term with highest power and the term here with the highest power is 7x to the power of 5. That's the leading term. What about the leading coefficient? Coefficient. Coefficient is the number in front of a particular term. It's a multiplication factor in a way. It's how many of them that you have. So that's a coefficient. It's the coefficient of x to the power of 5. That's the coefficient of x to the power of 4. A negative 2 is the coefficient of x squared. So the leading coefficient here is just 7. It's the coefficient of the leading term. One other word that's important is the constant term. What's the constant term? It's the term that's not affected by x. I guess you could say no x's in it. So it's constant. Like this term here, it changes depending on what x is. If x is 1, then 7 times 1 to the 5 is 7. But if x is 2, then that'll be 7 times 32, right? So that'll be 224 or something like that. And same with this one. If x is 1, then that term works out to be just 4. But if that x is 2, 2 to the 4 is 16, 4 times 16, it'll be 64. So these terms all change depending on what x is. But this guy here is a 3. This guy at the end is a 3, and it does not change depending on what x is. It's a 3. If x is 1, that's still a 3. If x is 0, that's still a 3. So it's constant. It's a constant term because it has no x's. It's unaffected by the changing value of x. So in this case, it's a 3. We often find the constant term by putting x equal to 0 and that'll reveal what the constant term is. But there may not be one, in which case the constant term would be 0. Okay. Say you have a polynomial, and I'll just mark out where the edge of the screen is here again so I don't go past it. This one is just here. Okay. Say you have a polynomial that's written out something like this. P of x is x minus 1, x plus 2, x plus 4, x minus 3. There's your polynomial. You could expand it out and have it written out the long way, or someone might have factorised it for you. There's a couple of words that we might be able to find when it's written in that way. The first thing is zeros of a polynomial, and the next is roots. Now these words mean much the same thing, in the same way as volume and capacity in most people's minds mean about the same thing. We know that volume measures the amount of space something takes up, and capacity is like a liquid measure of how much liquid something would hold, but we can actually convert between the two in that volume, its standard unit of measure might be cubic metres, and capacity, its standard unit of measure is litres, right? So say we talk about 1 cubic centimetre, that'd be equivalent to 1 millilitre. If they're equivalent, we can put an equal sign, we can convert between them. But as you can see, one's about how much space an object takes up, the other's about how much liquid would fill into an object if it was sort of hollowed out. So they're slightly different in meaning, even though we can kind of consider them in our minds as being quite similar things that we can work with, and we use the words interchangeably sometimes. And zeros and roots, it's the same thing. This polynomial here has zeros, talking about where it cuts the x-axis, right? Where the graph cuts the x-axis. So this is an entire graph. Most of it's not cutting the x-axis. Just rub this out and I'll give you a picture of what this entire graph might look like. It goes through the axis at x equals 1, at x equals minus 2, at x equals minus 4, and at x equals 3. Right? So this polynomial could look a bit like that, let's just say. And it's including all these millions of infinite number of points that trace out that shape, of which 4 of them cut through that x-axis. Those 4 are the zeros of that polynomial. The other word you might see is roots. Right? Now, zeros refer to a polynomial or a graph, whereas perhaps you think of it as referring to a graph of an entire function or a polynomial, whereas roots are talking more algebraically. They refer to an equation. Now, what equation are roots referring to? They're referring to the equation where this polynomial, x minus 1, x plus 2, x plus 4, x minus 3 equals 0. That's what they're referring to. I just moved that so you can see that. Roots are referring to where the polynomial equals 0. And if you solve that equation, you'll get the roots. The roots are x equals 1, 3, minus 2 and minus 4. They're roots of an equation. Now, where did the equation come from? Someone's probably taken the polynomial and said, where are its x-intercepts? Well, to find the x-intercepts, let's put this equal to 0. So we formed an equation where this polynomial equals 0. Now we're finding its roots. And the zeros of that entire polynomial there are the places where it cuts the x-axis. So you can see that the two things are pretty well interchangeable. Roots, zeros, we're asking for the same thing in the same way as capacity and volume, are very similar concepts. But there is a subtle difference as well. So when asked to find roots or zeros, in the end, you'll be solving an equation equal to 0 to get them, and most likely using the null factor law.